So, hello everyone. My name is Yeow Teck. I'm currently a third-year undergraduate from Xiamen University, Malaysia. And today I'm going to present my proposal, namely the valorisation of POME, sediment, and OPF as the substrate for Black Soldier Fly Larvae. And here's the agenda for today's presentation. I'll start off with some of the background and introduction for this research proposal, and then the methodology, and then the research impacts that we wish to achieve after we implement the project. And then lastly, the Gantt charts and also our plans to submit our manuscript to the selected journal. And here's the list of supervisors. Dr. Tan Jianping is also here. He will be the main supervisor for this research project, and he is the assistant professor for the Department of Chemical Engineering, Xiamen University, Malaysia. And we also have Dr. Norazira and Dr. Hui, both from the Department of Marine Science, XMUM. So I will start off with the background and introduction. So in 2021 alone, around 80 billion tons of the crude palm oil, CPO, were produced, and along with the production of CPO, there were a lot of palm side streams are also generated. Two of the major palm side streams include the palm oil milk effluent POME, which is produced at the rate of 3 meters cubed per ton of CPO produced, and another major source of palm side stream is the OPF, which is produced at the rate of 11 tons per hectare per year. And due to the large volume of production, both of these wastes are usually discarded to the natural body, thus causing very severe environmental issues. However, both of these wastes actually contain very high nutrition, and for instance, POME contains 38.5% carbon and 2.7% nitrogen, while OPF contains 64.7% carbohydrates and 9.4% protein. However, the nutrition embedded inside these wastes are rarely being tapped into. So here we propose to, we would like to propose a new waste degradation method to fully utilize the nutrition embedded inside them by feeding them to the saprophagous organism. So one of the most famous saprophagous organism is the larva of Black Soldier Fly, or known as BSFL. And similar to other insect species, the BSFL will also hatch from the eggs after incubation. And the stage of BSFL is the only feeding stage throughout the entire life cycle of BSF. And the BSFL can basically be fed on almost every organic waste. And this is also the research focus of this project, where we will investigate the feeding of POME, sediment, and also OPF to the BSFL. And after BSFL have gained enough energy through feeding, it will undergo metamorphosis into pupae. And then following that, the pupae will emerge as the adults. The adult BSF look very similar to the housefly that we see every day. The adults are only involved in mating and reproduction, but not ingestion of food. So unlike housefly, they will not carry any pathogens from the decaying food. So this is also one of the major advantages of BSF as compared to other insect species. However, if we simply feed the BSFL with random organic waste, it will not grow as what we expect it to be. Here, I will provide some insights to you regarding the effect of substrate to the growth of BSFL. Here, based on literature review, the researchers have fed the BSFL with soybean residual curd, SRC, and also waste coconut endosperm, WCE. So SRC is mainly made of simple molecules with 15.4% crude protein and 3.9% fats, while WCE contains mainly complex molecules with 30% lignin, 27% cellulose, and 27% pentosins. So when the BSFL were fed on SRC, we found that the protein content was 52% as compared to those fed with WCE, which contain higher amount of fat. So here we see that the composition of the substrate will significantly influence the composition of the BSFL biomass harvested. And besides that, when 500 grams of both SRC and WCE were fed to the BSFL, it was found that around 245 grams of the SRC could be consumed by BSFL, while only around 48 grams of the WCE could be consumed. So what makes such a big difference? And the reason behind is because BSFL can hardly ingest a substrate contains of very complex molecules. So in the substrates that we are going to investigate, the POME sediment could contain up to 7,600 milligram per liter of oil and grease, while the OBF could contain up to 14% of lignin. And the presence of oil, grease, and lignin will definitely impede the ingestion of the substrates by BSFL and slow its growth. So we propose to blend the substrates in order to lower the ratio of the complex molecules and also to improve the nutritional profile of both of these low-value substrates. And we believe that blending itself is not enough, so the blended substrate will also undergo in situ microbial fermentation, where by the microbial strains known as the B. subtilis. The reason we chose B. subtilis is because based on literature review, B. subtilis can degrade oil and lignin, and we believe that the BSFL fed on the blended and fermented substrate will grow happily and also healthily. And here's the methodology for this research proposal. We have subdivided the project into 4 phases. So I will walk you through the methodology through this workflow. In phase A, we will basically do all the preparation work where we procure all the required materials such as the POME, OPF, and also the bacteria. And also we will revive the B. subtilis and multiply it to the numbers that we desired. And then in phase B, we will start to prepare the blended substrate in different weight ratios as shown here. And all of these blended substrate will undergo fermentation by B. subtilis in an oven at 30 degrees Celsius for a day. And then after fermentation, we will analyze the composition of the substrates, and then we will get the CON ratio. And in phase C, we will feed the blended and also fermented substrate to the BSFL. We will wait and observe until about 80% of the total population emerge as the pre-pupae. We will collect the data such as the life history characteristics and lipid and protein yield of the BSFL. And then after that, we will correlate the data we collected with the CON ratio in order to build mathematical models to be used as inference for accurate calculation in the future. And in phase D, we will weight the residual substrate, which means those substrates that are not consumed by the BSFL. And through this, we will understand how well the substrates can be consumed by the BSFL. So here are some of the research impacts that we wish to achieve after we implement the research project. Firstly, we wish to establish a circular bioeconomy where we will procure the POME and OPF from the palm oil sector. And after that, we will feed it to BSFL, and then the grown BSFL will be valorized into various value-added products such as the biofuel and also animal feed. The excretion from the BSFL, or known as the frost, is found to have very high amount of nitrogenous-based compounds. So it will be used as the fertilizer to fertilize oil palm tree, and the oil palm tree can be grown and be harvested again. Another round of POME and OPF can be created, and then this is how we wish to establish this circular bioeconomy. And then the valorized BSFL into the value-added products, we believe this will be an extra source of income to the palm oil mill, palm oil sector, and it will act as an encouragement for the palm oil sector, especially the palm oil mill owners, to practice proper waste management through this cheap and simple technology. So here's the Gantt chart that we have included in our proposal. So in February and March, we will basically do all the preparation work such as procurement. And then in April, we will start to revive the freeze-dried bacteria and multiply it. In May and June will be the core periods for experiments where we will feed the BSFL, observe their growth, and then obtain the data we require. And then we will also observe the biodegradability of the blended substrates. And in July, we will mainly compile the results we obtain and then compile it into a written manuscript to be submitted to a selected journal. So if everything goes on plan, we plan to submit the manuscript to the Journal of Oil Palm Environment and Health by the end of July next year, 31st of July 2022, with the substrate and with the title Valorisation of POME and OPF as the substrate for Black Soldier Fly Larvae. So that is the end of my presentation. So here's the list of reference that we have referred to when we construct the proposal. And lastly, I would like to say a great thank you to a.k.a. POPSIG and BOC for being very generous in supporting this project, and it would not be possible without the support from both of these organizations. Thank you.